Tomorrow we'll grade the book work, but the AP packet I'm even going to hold up and let you have it until Tuesday to get that. Tomorrow will be a work day. AP packet you can work on tonight somewhere, whatever you want to work on tomorrow. Tuesday we will do more AP packet, which I'll actually assign another AP set tomorrow night. So we'll be working on the AP packet next week as well. Your test will be Monday and Tuesday of the following week. That would be the 14th and 15th. So next week, 8th, 9th, 10th, 11th will be all AP packet, and the Friday we're going to play an integration Jeopardy game. We did a derivative one in the fall, so and then the next Monday, Tuesday will be your test. So we are in review mode. Today is the last new lesson. Okay? So this is an AP problem. It's multiple choice. The AP problem I didn't finish working yesterday, number 2 and part of number 3, or part of number 2 and number 3. I will work those in class tomorrow. So this is the graph of the function f above this is 4 semicircles. If g of x is the integral from 0 to x of f of t dt, where is g not negative? Well, would you agree that from 0 to 2, definitely not negative? I would even say from 0 to 3, not negative. Because that positive area outweighs the negative area. Okay. What if I go backwards? That's all negative, is it? Oh, and why are we going backwards? 0 to negative 2 actually would end up being positive because you're going backwards with a negative area. So it actually turns out that all the way from negative 3 to 3 would end up being non-negative. At 0 it would be 0, but it doesn't say positive, it does say non-negative. So I can go straight from negative 3 to 3. Any questions about that? Okay, so if I integrate this way, positive area outweighs. If I integrate the other way, I'm going backwards. So even though it's negative, it becomes positive. Okay, the last new piece of information, everyone listen. The last new piece of information for this chapter is how to find the average value of a function. Before I talk about what that is, I want to talk about some other averages that you know how to find. Okay, we have talked about finding the average rate of change, which is the slope. We talked about the mean value theorem, which relates average rate of change to instantaneous rate of change. So, to review, that means derivatively the average slope at least one point in the interval. Today we will learn a different average, and that's average value of the function. So, before we actually get to the formula, let's talk about how to find the average value of a function. Say we were talking about a function that was discrete data, so points, data points. How do you find the average? Add them all up, divide by how many there are, right? However, brings us to the average value of a function formula. This is what you need to write down. You need to memorize it. And I want to say this again. This gives you the average value of a function, not average rate of change. So I have some more examples of this later, but just to really emphasize what this is. So say I have a position function, and I want the average position. That's how I do that. Okay? Say I have position function and I want average velocity. What would I do? That would be f of b minus f of a over b minus a, right? Average velocity would be a slope. But if I want the same function that I'm on, and I just want an average value, that's when you use this. You want to stay on the function you're on and use the average value of the function. What is the average value of sine of x from 0 to 5? So an example using it before I go into another y. I'm going to use the formula. 1 over, what's b? Pi. What's a? How do you find the average value of each one? Okay. Questions about that? And how do I do that? What was it? Good. Anti-differentiate to find the antiderivative sign, which is negative cosine. So 1 over pi times negative cosine of x evaluated from 0 to pi. What's cosine of pi? Negative 1, negative 1 makes a positive 1. So I get 1 over pi times 1 minus, if I plug in 0, I get 1. I get 0. Well, think about that. Sine of x from 0 to pi. Right? This. Oh. Cosine of 0 is 1. No, minus negative, right? 2 over pi. Why did I say no? That doesn't make sense. It's always positive, so the average value should be a positive value. From 0 to 2 pi, it would make sense to get a 0 there. Any questions about that? Another way to think of the average value is in terms of area, right? We know that an integral gives us area. Well, if there is some rectangle that has the same value as the integral, right? Some rectangle, same value, with the same height to make it a rectangle, a perfect rectangle. So if I took up b minus a, the width, and multiply it by the average height, right? That would give me the integral. Would you agree? The average height, this area under here, would give me the same value as this area under here. The area of a rectangle is based on height. Area of function is integral, so b minus a times the average value gives me the integral. If you divide both sides by b minus a, you get the same formula. So that's another way to look at it, just a geometric way to look at it. The average value is the height at which which you would get a rectangle that's the same size as the area under the curve.
That little line on the x
that stands for average. If you take a statistics class, you'll see that a lot more. But if you have an X with a bar over it, it's the mean. So it's average of f of x, of all the f of x values. It's another way to look at the y graphical approach. Okay. Very important note. Very, very important. Students hear average and do one thing. Unfortunately, there's two different things that we can do. There's average rate of change. There's average value. So when you're given a problem with the word average, you have to decide which one you're doing. Average value, we're going to do the integral formula. Average rate of change, we're doing f of b minus f of a over b minus a slope. It's easy to decide which one to use if you think of what you're trying to find. If you have the equation for the thing you're trying to find, so example, if you have velocity and you want average velocity, that is average value. Stays on the function you're on. It gives you the value of whatever function you put in. If you're asking a rate of change question, or say you have velocity and you want the average acceleration, that's a slope question. So that's where you use average rate of change. Does that make sense? So if you want to stay on the function you're on, you do average value. If you want average rate of change, that's when you use slope. So the next one, the example says, records indicate that T hours past midnight. The temperature at the local airport is given by that function in degrees Celsius. What is the average rate of change in the temperature between 9 a.m. and noon? We've been doing this question since we were second chapter of calculus, right? Average rate of change, very old hat question. Has nothing to do with the new formula. How do you do average rate of change? F of b minus f of a over b minus a. So f of b would be the temperature at noon, right? How am I going to find the temperature at noon? Plug one in. 12, how do you know? 12 hours past midnight. So f of 12 minus f of 9 over 12 minus 9. Everyone know how I got that. And so I would get, someone would factor in that. Oh, like that. Okay. What is our unit on that? Degrees Celsius per hour, right? My temperature is changing, so evidently my temperature is dropping for some reason between 9 a.m. and noon. That sounds rare, but whatever. So the temperature is changing by 2.3 degrees Celsius per hour. Does that make sense? That is an average rate of change. We asked, what is the average temperature at the airport? That's a very different question. That wants to know, of all the temperatures that happen between 9 a.m. and noon, Yeah.
That's another clip.
What we get? What we get? 18.7?
Yep.
What are my units? Degrees Celsius. Thank you. Why is it degrees Celsius? It's just the average temperature. I didn't change function, so my units are the same as they were at the beginning. Does everyone understand that? Alright. Find the average value of fx, which equals negative 2x plus 4, x plus 1, and x squared plus 5, and x is greater than or equal to 1. It probably would help me to draw a quick sketch of this to see what I'm looking at. Right? Probably don't have to, but it would probably be helpful. Okay? I did draw a quick sketch. At 1, I have a break in the graph. Everyone agree? To the left of 1, I have the graph negative 2x plus 4. Something like this. Questions about that so far? And x squared plus 5. Right there, and then at 1, that's 6. So up here, and then we've got a parabola happening. I want the average value from 0 to 4. I can't integrate this straight across, can I? It's got a break in it. Doesn't mean I can't integrate it. But I can integrate from 0 to 1 and then from 1 to 4, the different pieces. And that'll give me the area under the curve. How am I then going to translate that to average value? True, but I want the whole average. What are we going to divide by? Which is 4. Because don't we just want to add up all the points and divide by 4? We don't really want to look at the averages as 2 separate averages. We want one whole average. So the 2 subs we'll have to do separately. That makes sense. So I'm going to do 1 over 4 minus 0 times 2 separate integrals. The integral from 0 to 1, which one is going to be the one from 0 to 1? Plus the integral from
1 to 4.
Okay, so the first piece will give me the area underneath the line. The second piece will give me the area underneath the parabola. Those are adding up all the y values from 0 to 4. And then I'm going to divide all of that by how many y values there were. And so that's where we get the 1 over b minus a. Any questions about that? Dividing by the distance between 0 and 4. Someone type that in your calculator. Can you type that whole thing in your calculator? Yes. Does that mean you shouldn't practice antiderivatives at home?
Yes.
No, this might be non-calculator. This question, actually, I probably would say it probably is non-calculator. Would you agree? We're only going 0 to 1, 1 to 4, very workable numbers, very likely to be non-calculators. But in for good use of time, because I know you already know how to anti-differentiate, right? We can put that down. What do we get?
9.75.
9.75.
I just can't find that on my head.
Why did it do that?
Well, am I right?
Actually, yes.
Really? Boom.
What is it?
You didn't believe me, just kidding. Well, Was that right though?
Did you anti?
No, I just guessed.
You did.
It looks like it would be backwards, so I just counted the boxes. That kind of.
Alright, any questions about that? Okay, if the function f is given by x cubed has an average value of 9 on the closed interval 0 to k, then what is k? How would I set that up? Calculator probably won't be very helpful on this one. Everyone agree? Okay, calculator probably won't help me on this one. I'm gonna have to do some anti-differentiation on my own. Not that that's horrible, it's only x cubed. So what's the antiderivative of x cubed?
4x. It's x is 4 over 4.
Plug in the k, plug in the 0, right? Right? So I get 1 over k times 1/4 k to the 4th minus 0. I know that equals 9. What's k to the 4th divided by k? K third. K cubed, okay, if I go ahead and make that equals 36. So what is the answer? Cube root, and what's another way to say the cube root? The 1/3 power. So e, the 1/3 power. Any questions about that? Good. Okay. I'm going to cross out your average, and these dates are probably wrong. No, dates are wrong. Hold that thought. I'll get you new dates. So there was a different day, like Tuesday. I don't want to sleep. So okay. So, I don't know, maybe I've changed.
Okay.
Okay, the average value of the function says due tomorrow, but that's actually going to be due on Tuesday. I'm going to give you, because tomorrow we're having a work day, so you might as well be able to work on it too. So that's up to you how you do that. So that's due Tuesday. Along with, everyone listen, along with 4 through 8, and along with the page that you had last night. All of that is due on Tuesday. So everything you've got is due Tuesday.
Okay, so those.
Yes, everything you've got is due Tuesday.
9 through 12 and 13 through 16 are listed.
Yes, 9 through 12 due Wednesday, 13 through 16 due Thursday, test Monday, Tuesday. 9 through 12 is due Tuesday. I have that the gateway is due Wednesday. Let's go ahead and get the gateway done by Tuesday also. So let's move gateway to Tuesday. 9 through 12 is due Wednesday. Here, it's correct. It is correct. So everything you have is due Tuesday, 9 through 12 due Wednesday, 13 through 16 due Thursday. Any questions? I do want the gateway done by Tuesday, that way we can grade it. You have the answers. I want to remind you, I said this already, and I don't know how well you believe me or not. Last year on this exam, the people who did not know the gateway, I'm not saying the ones who missed one problem, right? That happened. But the people who came in and didn't know how to do the gateway bombed the test. You cannot do the test if you don't know how to integrate. So even though you are having to get the gateway in before the test, you are going to have to do a little extra on your own. Make sure that you are good enough at the gateway, right? You know what I mean by that? The test is over integration. So if you can't integrate, I don't care if you pass the gateway the first time or not, right? You can't integrate, you're not going to do well at the test. So you've got to get to where you can integrate. Monday's part of the test will include the gateway. But, again, even though you'll get to retake that part, I did really like last year's 10-point bonus points for anyone who gets the gateway right the first time. That still stands. If you get the gateway right the first time, you get 10 bonus test points. You will get 60 out of 50 on that part of the test if you get it right the first time. Of the average value? There should be. Daniel, were there any? Oh, you're there. Okay, any questions?
Gateway test did not. The gateway that's due on Tuesday, is that the paper that you gave us?
Yes.
Fill it out.
Yes.
Okay.
Just
We're not taking the actual.
Not taking the actual quiz Tuesday. I'm gonna make the gateway deadline 2 weeks from the first time we take it. So 2 weeks from the 14th. So 2 weeks from the 14th will be the last time you can take the gateway. Thursday. So what the board says is correct. Everything the board says is correct. Okay, any questions about tests, due dates, anything like that? Do we feel pretty good about what's coming? Nothing.